In our previous video, I demonstrated how StruCIM can be used to automatically generate a welding program for a robot in order to place web stiffeners and plates and clip angles on the main member of an assembly for structural steel. In this video, I'm going to take a peek at how we can hand edit welds if we have collisions or awkward positions for the robot. So the first thing I'm going to do is place the program in step mode, begin my simulation, and you can see that on the first weld we've got the arc gun colliding with the flange of this beam in order to get to the weld. I'm going to zoom in a little bit more. I've got my hand on the Alt key with my 3-button mouse so I can pan and zoom, move my camera around. So now when I want to edit the weld, I double click on the weld statement in the program, and you can see that immediately we pop up a panel to hand fix welding paths along with our test path panel and the move object panel, and you'll see how these all work together. The first thing I'm going to do is go to the test path panel and find out which one of these frames is problematic, and you can see that that position right there places our arc gun at an angle such that it collides with the flange, and that's just not acceptable. So I'm going to go and show you that in the hand fix menu we can orient all the frames of a path to align with the current orientation of the arc gun, or we can simply reorient the current frame. So what I'm going to do is I'm going to use the move panel, which you can see is already configured to rotate the arc gun about the y-axis of its tip. And I'm just going to go right in the graphics, and I can grab and drag the gun to move it to any angle I desire. So I'm going to bring it to a more upright angle here. And you can see that that's going to fix one problem, but introduce another. For now, what I'm going to do is I'm going to rotate the tool to what I would consider a reachable angle. And when I click Orient Current Frame to Arc Gun, it not only moves that frame, but the approach frame as well. So if I go back to the Test Path panel, click on the first frame, you see that it's now approaching in a direction along the normal of the target frame here. You can see since we reoriented only the start frame, we now need to do the same for the end frame. So I'm just going to use the Test Path panel to get there, move the tool to a similar angle, and once again say Orient Current Frame. So now if I go through my whole path, we've got our approach frame, we move along the normal, then our gun slides along the weld and retracts once again in the normal direction. Now finally, as you can see, this path is not perfect yet. We've got the tip of the tool colliding with the plate itself. So what I'm going to do is translate the frame, move the tip of the gun just a little bit away from that intersection of those two surfaces, and we're still going to end up with a viable weld. So I'm going to move the arc gun. This time I'm going to move it in the XZ plane. Scratch that. I'm going to move it in the YZ plane. And just along the y-axis, I'm going to slide. And once again, I click and drag in the graphics windows. You can see the tip move as I drag. So I'm going to move until the tip is no longer intersecting or colliding with that surface. Move my camera around to make sure that I've got a good angle here. Move it a little bit more. And now I'm going to translate every frame in that weld to reflect that change. So now if I go back finally to the test path panel, I'm going to zoom out a little bit so you can see where the approach frame is. Now I click on the second frame. You can see I come in, clear the flange, slide along the weld once again in position where the tool can access the weld without colliding with the flange. And again, this is going to be an acceptable distance away from my surface intersection. And when I click on the final frame, you see the gun retract. All those changes are made immediately to all the weld positions. So if I zoom out here, reposition the gun, and perform the weld, you can see that it's dropping down clear of the flange, sliding along at a slight offset from the surface intersection, and retracting again without colliding with the member.